It's called Dallas 2006, or it's called 2006.
2006.
Correct.
Yeah.
And we just went through the prompt. There's a radio owner who has 3 different types of music they can play, and they have 3 different audience types. And if you look in this chart right here, you've got rock, country, and rap, which are your 3 primaries. And you've got different audiences. So A1 audience typically affiliates with rock, audience 2 country, and audience 3 rap, and they all have different higher view rates. And the view rates or the dollars are based on revenue in thousands of dollars, revenue based on each type of listener, and this is advertising revenue. First thing that he wants you to do is build a decision tree, which he's provided to you, and that decision tree is right here. And so we have to go through and fill out the variables at different spots. We've got to fill this one, and this one for our first step in the process. No, I don't want that. So first build this. And the values, the variables.
It's just to maximize revenue.
Yeah. So and the goal is to maximize revenue because we're here to make money and not fuck around. So, build this first, and these are your associated probabilities. All right. So.
And they're already in there.
They're already in there when you get the thing open. So first build that. Explain the best course of action that the station owner should take based on your decision tree.
Well, I got a question.
Okay.
So problem 1A isn't a problem. It just gives it to you.
Yeah. Like 1A is just construct just construct the thing.
But it says use the following diagram, so it just gives it to you.
Yeah. So he says build that, but build it to where you can...
It doesn't maximize it, though. This has all of them on there.
Yes.
There's something
this is just what you need to build. This is the first... Based on decision tree. The best choice should be country, of course, since the expected value is higher for that alternative. So you're looking at the expected value. You've got...
He inputted this wrong in the sheet.
What are you talking... Oh.
He did it wrong. That should be 90.
Oh, let me go pull it. So Clay says that right there is wrong.
Does it look to be wrong?
So that should actually be 90. Good catch, Clay. So to edit, by the way, everybody, you go to the little red node, click the red node, go to branches, and then you click here, and you change this to 90.
And you click change.
Yeah, and then you click OK, and it'll update it. So we've got our 90 back. Okay, so...
Mine turned red. Is there a reason that happened?
Yeah, so the line... So Clay's branch right here turned red. All you do is click on A2. Or wait, no, don't click on A2. Click on the red button.
The node?
The red node,
okay.
Yeah. And then under branches...
Oh, that's because I went like this.
There's a check mark, yeah. He had a check mark in this box right here. Okay. So don't do that, and you won't get the red branch.
Whatever that actually does. Probably
yeah.
Nothing, but...
Hopefully nothing. Okay, now, so build that, you got that, and he says best choice is country. Woo, country! America! And the reason is, well, so he's asking for your rationale. So if you look strictly at the expected value... 97 for
country.
Yeah, it's 97 per country. For country, which is the highest overall.
Dude.
So...
Well, if your only choice is to pick country and you have no direct control over those probabilities, which you don't, then 97 would be the expected value.
Yes.
So, yeah.
So you're expected to make the most money based on country music.
Correct.
All right. So let's just write that highest EV
that's like the aggregate.
Yeah, highest expected value.
Yeah.
So what is the most that the radio should be willing to pay for any survey that would predict the type of listener it could expect? So use the following decision tree to assist in answering the question. Alright, we're getting a little bit closer. Now we need to change these nodes right here into decision nodes. And those...
That's what he did, because remember, he switched...
Tricky fucker.
He said that was one of his last sessions. He said, what was the reason you switched the decision? You moved the chance node to the front. Mm-hmm. When's the scenario when you do that? He said it.
I can't remember.
Okay, so that's what he did.
So let's review that at some point.
Good catch.
Now we got all of our values update to where they should be. This makes more sense, I think. Alright, let me just do a little erase. Okay. Alright, 110, 120, 140. 110, 120. Alright, now we're good. Now, so keep your eyes on these. These will drive you crazy.
No, we're on.
So that switching of the nodes, whatever was said during class, let's key in on that, because that's something that he's looking for.
I've got it in my mind. There's a time when you move the chance node to the front.
Okay, so moving chance node to front. Let's change colors for this. Move chance node to front. Okay.
C is the value of information. That's when you move the decision node to the front, when you know when someone's telling you what's going to happen.
Okay, so
it's value of information is what he called it. Expected value of perfect information. That's what EVPI means. That's when you do it.
Okay, so this is our imperfect information.
You switch whenever you've got imperfect information. That's when you move the chance node to the front.
Mm-hmm.
I remember him saying that in class. That's what he said. And when I saw that as this, he gives you this is the answer right here.
Mm-hmm.
It's
so you take 121 minus 97.
So 121 is the overall expected value. The value before you switch the chance node to the front.
Yeah, so we just took a little bit to figure out what it was, but you get your first, when you do the decision tree the first time, you get your expected value of 97, okay? Then, when you switch the node,
Perfect.
that is perfect information.
When you get perfect information, you move the chance node to the front.
Yes. So you're willing to pay $24,000. So you build out your decision tree. Then you're gonna switch it to get perfect information. You take the expected value from the first tree, subtract it from the second tree, and it'll tell you how much money you're gonna make.
Oh, and something else changed too that you might not have caught. The nodes didn't only switch, but at first, off the first node, it was the 3 music types, and the audiences were last. Then we switches to the audience types at the front and the music type at the end.
Okay.
It's simply a label thing. I don't think it affects the numbers. At least it shouldn't have, right?
That is a labeling thing, but the logic behind it is that you have rock, country, and rap.
Yeah.
And then you have then you have the probability. Yeah. So okay.
Theoretical thing that I had a grip on in class. The label switch.
Mm-hmm. Okay, so build tree, type, and value. And this is what's the green one? A chance node?